Today here we discuss about the radioactive radiochemistry, nuclear and radiochemistry. In this chapter we discuss about the law of radioactive decay or the general rule. First, upon we see here what is some basic concept of atoms related to atom. We know that there are two parts or in atom. The nucleus. In this nucleus, suppose this is the structure of atom, and this is the shell. This is the shell. Suppose this is nucleus. In this nucleus, we know that there is a presence of protons and neutrons, and this is the orbiting electrons. So, then the next concept is the isotopes. Isotopes are those species of a particular element which having same number of proton but different number of न्यूट्रॉन्स आयसोटोप्स म्हणजे असं अशी स्पेसिस आहे की एखाद्या पर्टिक्युलर इलेमेंटमध्ये त्याचा ॲटम प्रोटॉनचा नंबर हा असतो तो सेम असतो बट न्यूट्रॉनचा नंबर जो असतो तो डिफरंट असतो त्याला आपण आयसोटोप म्हणतो इट्स कॉल्ड ॲज द आयसोटोप्स इलेमेंट्स हॅविंग सेम नंबर ऑफ प्रोटॉन्स बट डिफरंट नंबर ऑफ न्यूट्रॉन्स मोस्ट ऑफ द isotopes are naturally occurring and those are those isotopes are stable isotopes. Those isotopes are stable isotopes. But some isotopes which are man-made or human-made, and they which is man-made isotopes which is very unstable. So unstable becomes unstable isotopes become stable by the releasing different types of releasing different types of particles, and this process is called as the radioactive decay. And the element which undergoes such type of decay is called as the radioisotopes, and the product of this decay is called as the daughter isotopes. First, isotopes means the elements having the same number of protons but different number of neutrons. Some isotopes are naturally occurring, some are man-made. Those are naturally occurring, which isotopes is stable, but those isotopes which is man-made, those are unstable, and these unstable isotopes becoming stable by the releasing different types of particles, and this process is called as the radioactive decay. This process is nothing but radioactive decay, and the element which undergoes such type of decay is called as the radioisotopes, and the product of this decay is called daughter isotopes. Then here, what is radioactive decay? Radioactive decay, also known as a nuclear decay, radioactivity, radioactive disintegration, or nuclear disintegration. There are four names, different names. We call radioactive decay is a nuclear decay, radioactivity, radioactive disintegration, or nuclear disintegration. These are the four different names. Is the process. It is a radioactive decay is the process by which unstable atomic nucleus, which is lost energy by the radiation. Unstable atomic nucleus which lost energy by the radiation is called as the radioactive decay. Then a material containing unstable nuclei is considered radioactive. Material containing unstable nuclei is considered as radioactive, and there are three most common types of decay. There are first is the alpha decay, second is the beta decay, and third is the gamma decay. Then next, alpha decay. First is the alpha decay, and alpha decay include the decay by the alpha particle, and alpha particle is the helium nucleus. Is here decay means decompose किंवा तुटणे या लँग्वेज मध्ये म्हणू आपण अल्फा डिके मीन्स डिकम्पोज और तुटणे मग हियर अल्फा डिके इज include decay by the alpha particle alpha particle include असतात आणि which is identical to helium nucleus. We know atomic number of helium is 2 and here atomic mass number of helium is 4. This is atomic mass number, this is atomic number of helium and this helium and this alpha particle is which is equal to this helium atom. So here in general we give one equation or reaction. Suppose this is and this is one atom which Z is the atomic number and here A is the atomic mass number. If we bombarded here alpha decay or alpha radiation or alpha particle, we have the here suppose Y is the we have here Z is 2 and A is here 4 which is equal to the helium nucleus. Here before radiation of alpha decay this atom is the unstable and after radiation of alpha decay or alpha particle we have the stable atom. For example here we give uranium 230 for here this is uranium atom, this is our atomic number uranium 92 and this is 234 atomic mass number. It is the most common isotopes. If we bombard alpha decay in this atom, then we have thorium. Here, if we here 4 minus, so here 230 or here 90 plus helium. Then next is the beta decay. Beta particle is the fast particle moving electron which is emitted from the nucleus of an atom undergoing radioactive decay. In this beta particle is the fast particle moving electron and which is emitted from the nucleus of an atom undergoing radioactive decay. Suppose this is a general reaction. Suppose here X is an atom, here Z is the atomic number and A is the atomic mass number. If we radiated beta particle in this atom, first this atom is unstable. Again, if we bombard or radiated beta particle in this atom, then we have the here stable atom. 1 plus 1 is here added. So, in suppose this is example of beta decay. Here 218 polonium, polonium 84 atomic number and here 280 atomic mass number. This is the unstable atom. If we radiated beta decay in this atom, we have 80, 85, 85 to 80. This is stable. We have this is stable atom. This is the beta particle. Next and the last is the gamma decay. When atom decay by the emitting alpha and beta particle to form a new atom, the nuclei of the new atom form still have the energy to be completely stable. This atom will emit gamma ray release energy. Gamma ray is high energy radiation and the gamma ray are not change particle like alpha and beta particles like this. Here we see that suppose this is the general reaction. Say suppose this is one of the atom, here atomic number, here atomic mass number. If we bombard gamma radiation in this atom, we have same atom. Gamma rays are not change particle like alpha and beta particle. So we have this general reaction and gamma ray is high energy radiation. For then the next is the radioactive decay. The concept of radioactive decay. According to the radioactive decay law, when a radioactive material undergoes alpha, beta, or gamma decay, the number of nuclei undergoing the decay per unit time, and it is proportional to the total number of nuclei in the sample material. Suppose this is our sample material or radioactive material. If we bombard it, suppose this is the gamma ray, this is the alpha, or this is beta ray. If we any ray bombard this material, then the number of nuclei undergoing the decay per unit time, and it is proportional to the total number of nuclei in the sample. So if capital N is the total number of nuclei in the sample, and delta N is the number of nuclei that undergo decay in the at time delta T. Then we have here the number of nuclei undergoing decay. So total number of nuclei in the sample is N, and delta N is the number of nuclei that undergo decay in time delta T. So delta N divided by delta T, which is proportional to the total number of nuclei. So here we give one constant. This is lambda, and delta, or we have the equation delta n divided by delta t equal to lambda n. This is equation number 1, and this lambda is the radioactive decay constant or disintegration constant. Then now the change in the total number of nuclei in the sample. Changing the total number of nuclei in the sample, dn is equal to minus delta n. Here minus delta n because we here decay means the particle is decomposes or break down. So here use our negative sign at time delta t. So hence the rate of change of n in the limit at delta t gives 0. So here we know with the formula our equation here delta n divided by delta t equal to lambda n. Only here we add minus sign and changes number of nuclei. So dn divided by delta t equal to minus lambda n, or if we rearrange this equation, we have dn divided by n equal to minus lambda dt. Now integrate above equation on both sides. We get integration n0 to m dn by n is equal to lambda integration t0 by t into dt. Then here we have after solving integration, we have l minus l naught equal to lambda t minus t0. This is equation number 3. M naught is the number of radioactive nuclei in the sample at atom arbitrary time t0, and n is the capital N is the number of radioactive nuclei at any subsequent time small t. So log n divided by n naught equal to e raised to minus lambda t. This is equation number 4. If t is equal to 0, third equation rearrange, we have ln n by n naught is equal to minus lambda t. So after rearranging this equation, we have n of t equal to n naught into e raised to minus lambda t, and equation 4 is the law. This is the equation of law of radioactive decay. Thanks for